Okay. All right, then here we go. Before I launch into solving, I want to do a little bit of clarification on restrictions. If we still do the supplemental assignment because of this whole change and time purposes and stuff, we're kind of debating on that, to be honest, but if we still do the supplemental assignment, it is going to be centered around restrictions. Okay, so I'm not going to go into them in too much detail because the whole point is for you to be able to explain it, but I do want to go over a couple things because I think some people are still getting a little mixed up when it comes to restrictions. Okay, so basically when it comes to a restriction, if you remember from rational expressions, the restrictions were anything that made the denominator 0 because you can't divide by 0. It's impossible. All right, if you try to plug it into your calculator, it will say error. It's considered undefined. It doesn't make any sense to divide something by 0. So the restrictions came from anything that made that denominator 0 because that's impossible. For radicals, it's going to be anything that makes a negative under a square root sign, but only a square root sign or any other even numbered index. Okay, so if it was a square root, a fourth root, a sixth root, anything that has an even number in this index, you can't have a negative in here. And the reason is because a square root is the opposite of squaring something. So if I had negative 2 to the power of 2, that's going to give me positive 4. If I had negative 3 to the power of 2, that would give me positive 9. No matter what, when you're putting it to an even numbered exponent, you are going to get a positive answer. So for that reason, it's impossible to take the square root of a negative number because you would never ever square something and get a negative answer. So that's why you cannot take the square root or any other even numbered root of a negative number. It doesn't make any sense because if you put it to an even numbered exponent, you would always get a positive answer. Does that make sense? Okay, so if it is a cubed root or any odd numbered, you actually can take the cubed root or any other odd numbered. Because if you take negative 2 and you put it to the power of 3, you get negative 8. So because you are actually able to get a negative answer, it means you can take the cube root of a negative number. So your restrictions for a cube root would be something like this, x epsilon r. Okay, it can be any number. It can be anything. It is just these ones where it can't be negative that we have those restrictions. Okay, so if I had an x squared, well actually x squared wouldn't be a very good example, but if I had x cubed in here, for x cubed, I have to state that x has to be greater than or equal to 0. Because if x isn't greater than or equal to 0, I would get a negative inside that radical, and I can't take the square root of a negative number. Okay, but for your cube roots, that doesn't exist. It's fine. You can take the cube root of a negative number. Okay, so for any square roots or any other even numbered index roots, you do have to look at what your restrictions are. Now, one other quick thing I want to say about that is your restrictions always come from the whole radicals, okay, from the entire radical. So there was a question on the quiz where we went, I can't remember what the original question was, but we went from a mixed radical, and then the entire radical that you ended up with was 4xy squared. Okay, that's what you ended up with. That is what you pull your restrictions from, not the original question. This is what you pull your restrictions from. And only x has to be greater than or equal to 0. You do not need a restriction for y. Why don't you need a restriction for y? Nope. It's the same reasoning that I just explained. Yep, Darren, go. Exactly. It's what I just explained. It's why we need restrictions for this and not cube roots, right? If y is a negative number, I am squaring it, so it will become positive. So you don't need restrictions for y because it's to an even exponent. Only x would get a restriction there. Yeah. Nope, I didn't take any marks off. And honestly, I probably still won't. Because I know that that's a lot to try and wrap your brain around, but I just want to explain it. Like this, only x needs a restriction. Y does not need one, because you are going to plug a negative in, it's going to put to the power of 2 and become positive. So it does not need a restriction. This would be what you pull your restrictions from, the entire radical. So it started, I think, as 2y and then radical x. I'm pretty sure. That was the original question. We changed it to an entire radical. Our restrictions always come from the entire radical, not the original, the entire. Okay, so that's pretty much it. That's all I really want to say about restrictions. Okay, so anything that makes a square root negative is what you pull your restrictions from. Okay, and we say greater than or equal to 0 because anything less than 0 is a negative, right? So that's where that comes from. That's why we look at 0. So that's kind of the reasoning behind it. We're going to continue to look at all kinds of these. I just wanted to quickly go over that because I could tell from the assignment that a lot of people were still a little confused about the restrictions. Okay, so for each of these, so we are going to be solving. So you want to solve for x. So just like in anything that we do, when you solve for x, you need to isolate it. Okay, so right now, x is under a radical sign, right? So the first thing that I want to do is get that radical alone. So this -7, it's not under the radical sign. Someone didn't forget to like extend their thing. It's legit separate from it. This means radical 4x minus 7. So the first thing I want to do is I want to isolate that. So I'm going to add 7. Okay, so then I get radical 4x is equal to 20. Okay, and don't continue from here. Yes, I know a bunch of you are going to know how to solve from here. The other thing that I want to make sure I do is I want to make sure I state my restrictions. Okay, there's a reason I just rambled on about them for a while. The way you state your restrictions when it comes to these equations, when it comes to solving, is you take whatever is under the radical. So in this case, 4x. And because everything under the radical has to be greater than or equal to 0, you set whatever is under the radical greater than or equal to 0. And then solve for x. So I would divide by 4 on each side, and I would get x is greater than or equal to 0. Most of you could have told me that that was the restriction there anyway, and that's fine. They're going to get harder. Okay, so hopefully most of you get that. I think most of you could have told me that that's what the restriction was without me solving anyway. Okay, so x has to be greater than or equal to 0 in this question. All right, so we go back to our thing. So we've isolated x. We have radical 4x equals 20. I want to try and get to that 4x that's under the radical sign. So how do I get rid of the radical sign? Opposites. The opposite of square rooting something. Squaring it. Talked about that forever too. So I'm going to square both sides. All that happens on this side is those two things cancel each other out. When you square a square root, you are left with just what's under it. They cancel one another out. So we get our 4x that we are trying to isolate. What is 20 squared? 400, correct. 4x equals 400. How do I isolate x now? Divide by 4, cool. So we get x equals 100. Now with these, you always need to verify. I know verifying was kind of annoying with rationals, and we kind of did it sometimes and didn't do it other times. You always have to verify with radicals. And I just want to make sure. So identify any restrictions. And yeah, okay. So now we're going to verify. So you just plug it in. These ones are a little bit faster than rationals too, so that's nice. So verify, we just plug in 100 for x into the original question. So the original question was radical 4x. So 4x means 4 times x, so 4 times 100. Minus 7, so before you moved anything too, should equal 13. 4 times 100 is 400. Square root of 400 is 20. 20 minus 7 is definitely 13. So we get 13 equals 13. So we are good to go. That is not an extraneous root. Nick? I just said that, yep. With radicals, you always have to verify. It's not like rationals where sometimes we made you do it and other times we didn't. Radicals are a little weird where sometimes even if, so like x is definitely greater than 0, right? Sometimes you will get numbers that satisfy the restrictions but are still extraneous. So you have to check every single one. All right, so let's look at example B. So I have 5 plus radical 2x minus 1 equals 12. How do I isolate? Well, actually, sorry. Step 1, we want to do the restrictions. I'm lying to you. I'm already getting ahead of myself. So for the restrictions, so step 1 is always going to be restrictions. My bad. Sorry, got ahead of myself. So we take whatever's under the radical. So see, they're already a little harder. 2x minus 1 is what's under the radical. So we take what's under the radical, we make it greater than or equal to 0 because we know that we can't square root a negative. So we make it greater than or equal to 0. Then we solve. So I'm going to, you solve as if this was an equal sign, okay? So you add 1. Now it will occasionally make a difference that it's not an equal sign, but anyway, you add 1, you get 2x is greater than or equal to 1, and then you divide by 2. So we get x is greater than or equal to 1/2. So x has to be greater than or equal to 1/2. And again, that's what separates 0 from negative, right? If I plug in exactly 1/2 here, I'm going to get 0. So all other x values have to be greater than that, right? 2 times 1/2 is 1, 1 minus 1 is 0. So all of my other x values have to be either equal to 1/2 or greater than that. All right, so now that we've stated our restriction, we can solve. So now I want to isolate. So I'm going to subtract this 5. I have radical 2x minus 1 on this side. On the other side, I have 12 minus 5, which is 7. Okay, I want to get to the stuff under the radical. So I want to square each side. If I square each side, I'm going to get to that stuff under the radical. So by squaring it, I've eliminated the radical sign. I'm left with just what's underneath. So 2x minus 1. What I do to one side, I have to do to the other. So what's 7 squared? 49. Awesome. Add 1. We get 2x equals 50. Divide by 2. We get x equals 25. Then I want to check that really quick. And again, you always plug it into the original, not anything you've rearranged, the original. So 5 plus 2 times 25 minus 1, all under the radical sign, and that should equal 12. 2 times 25 is 50. I really want to skip steps here, but anyway. 2 times 25 is 50. 50 minus 1 is 49. Square root of 49 is 7. What's 5 plus 7? Right, so 12 equals 12. So our solution is good. Our solution is correct. Not only is it greater than 1/2, when I plug it in, I get that the left side equals the right side. So I know my solution is correct. All right. Now, I just want to check something really quick. Yeah, I've already been recording for more than 15 minutes. Never mind. Although it started at 7 something. I'm going to pause the recording for a second. I know I can only put 15-minute videos up,